as I said, I'm getting a lot of fun and a lot of satisfaction from this. I hope you do too. Okay, so we have r prime of x. What does r prime of x mean? So let's put it in here, which is what?
The derivative?
Yes, the rate of change. Also the derivative, yes. Derivative, but is the rate of change of revenue with respect to items, number of items. Okay, what else? It has another name. It's called blah, blah, blah revenue.
Is it marginal?
Thank you very much. That's the name of it. Thank you. Awesome. So R prime is the derivative of the revenue. And it represents the rate of change. How fast is the revenue changing for a particular X value? It's also called the marginal revenue. Awesome. Now, here's the question. What does this definite integral from A to B, let's say from 0 to 10 days, which is also the exact area under the graph of R prime, represent? It represents what? So let's say between 0 and 10 days. So this is the exact area under the graph of R prime. But what does it represent? Why do we even bother to calculate it?
Would it be the revenue between those days?
Excellent. The total. It represents the total revenue. Revenue between 0 and 10. And we had this here. We had the same concept here, but I used a different function. If the function is a velocity between 0 and 4 hours, what will the area? But now we already have the fact that, that's why I put it again, because we also have this expression, this notation, right? That's why I put it again. Is the total distance between 0 and 4 hours. Here, because I changed the function, I said, well, not velocity, but this is revenue, the rate of change of revenue, or the marginal revenue. If we want to determine the total revenue between 0 and 10, or between 10 and 50, or between 100 and 200, it doesn't matter, which is also the area under the graph of this, what it will represent? It's also the total revenue. Yes, good, awesome. Again, what does this represent? And what does this represent? So this is the definite integral, and this is the indefinite. Definite, it's fixed between 2 points, 2 values. Definite, indefinite. What does the definite give us? And what does the indefinite give us? What are these?
The definite is a number.
A number. Awesome. It's the area, it's the total distance, it's the total revenue, total cost. Yes, this is always a number. Awesome. And we can check it with TI-84. We can check. But what is the indefinite then?
It gives us an equation.
It's a family of functions. And can we check this? How do we check this? This we check only with TI-84. But how do we check this? What do we
taking the derivative?
Exactly. Awesome. Check with differentiation. Both sides. Awesome. To calculate the definite integral from a to b from f of x dx, what is the procedure? What should I write? How did we calculate it last time? What was the rule that we used?
fundamental theorem. Of
Exactly, yes. So we write f of x, which is the antiderivative of this function, vertical bar from a to b. And how do I calculate this?
FB minus FA.
Excellent. F applied, so F evaluated at B minus F evaluated at A. Please remember this is the rule. Okay. Question. We can or we cannot split a definite integral into a sum or maybe a difference of several definite integrals. We can or we cannot.
You can.
Yes. Yes, we did it last time. We can. We had this rule, this property, in which we were allowed to. It can go back and forth. So I can have this split into this, or I can have this condensed into this. Awesome. Very good. So we can. And finally, right here, last one, before we look at my lab math. This is my page 2. Okay. Given a function f of x, give me any function you want again, because I need to use this today.
X squared.
Good. The derivative is?
X cubed over 3.
No, the derivative. The derivative.
Oh. 2x.
Good. Awesome. The differential is?
2x dx.
That's it. Awesome. Great job. Okay. So finally, so this is a definite integral. What do I have to write here? Which is the same with what I write here. They are the same. Give me an
The
example.
differential one.
Yes, this is indeed dy. It's the function times dx. So please remember, no integral exists without d something. Since the function has x in it, it will be dx. If the function has t in it, it will be dt. So this will be 2x dx. Okay, so we always calculate a definite or indefinite from the differential of a function, f prime of x dx. Okay, enough of that. Well done. Thank you. Okay, so then we are going to continue with my lab math. And Sloan, forgive me, I don't remember which problem you...
Number 14.
Yes?
Do you want me to share my screen?
Yes, which section? Let me write the section for everyone. Yes, you can already share, yes.
I think it's 4.3.
4.3, excellent. So please do share so we can start. This is so much easier that I don't have to, because I have the book ready for the lesson, and it takes me out of it. Yes. Okay, so find, I think it says distance, right? So we have to find s of t, where s of t represents the position function or the distance function, yes, and v of t represents the velocity function. Good. So we are given v of t, which is 6t squared. We are also told that s of 0 is 4. Perfect. You can stop sharing.
Okay.
Perfect. So then I'm asked to find this. How do I find this given this? Any suggestions?
Add 1 to the exponent and then divide by that number.
Perfect. So I will write the indefinite integral from 6t squared dt. Because this is this prime. That's what this is, s prime of t. So s prime of t dt with the integral will give us s of t. Good. 6 stays outside as a factor. You already told me t to the third over 3 plus a constant c. Of course, I will write 2t cubed plus a constant c. But I have an initial condition. Initial condition. I am told when x is 0, s is 4. So 4 equals 2 times 0, which is 0, plus c, which is c. So now we have the function s of t. Can anyone dictate the function s of t?
Would it be 2t?
You can say it at the same time, that's fine.
Plus c cubed plus
Yes, plus
4.
plus 4. Very good. Other questions for me? Other questions? Is this clear, everyone? Okay, in that case, I would like us to go back to page, I'm going to share my screen now. Okay, I wanted to go back here. So we looked at page 425 and we had an example of the finding the area enclosed by the curves. Now I want to find this, 34 through 44. Find the average. It should be the average value. It's a mistake. Find the average function value. Yes. I should have read the whole thing. Yes, that's correct. Find the average value over the given interval for the given function. Correct. 34 through 44. Anyone?
Can we go with 39?
Let's do 39. So 39 on page 426. 39. So f of x equals x squared plus x minus 2, and the interval is 0, 4. So let me refresh your memory. So when we are asked to find the average value of a function, f average equals 1 over b minus a, the integral from a to b from f of x dx. This is the formula. Of course, this has to be a continuous function on the given interval. Of course, it's continuous because it's polynomial. They are always continuous. So then we have to write f average. I like to write it on 0, 4 so I know exactly what I did. Can anyone dictate what to write? Don't calculate anything. Just say you have to write this and I'll write it.
Is it going to be 1 over 4 and then of the integral and then 0 to 4 and then f of this function?
Dx. Perfect. Good. That's all there is to it. So 1/4 stays outside. I need a function whose derivative is x squared, and then plus a function whose derivative is x, and then minus a function whose derivative is -2. I'll put them all together, and then from 0 to 4. And then I apply the fundamental theorem of calculus. In here, I plug in 4, and I subtract when I plug in 0. So what do we have here?
X cubed divided by 3 plus x to the second divided by 2 minus just 2.
If I write just 2, this derivative will be 0.
Oh, 2x.
Yes, awesome. Good. So obviously, I will not have to worry about 0 because all of them will be 0. So I only have to plug in 4. So I have 1/4, 4 to the third, 64 over 3, and this is 16 over 2, which is 8, and this is also 8. I like that very much. So then I have 1/4 and 61. Let me write it like this. So this is 16. So the answer is 16/3. Let me show you again. I would like not to have to do this all the time, but you know, if we need to, we can. So here it is, my 41.666 from last time. So math number 9, it was from 0 to 4. And don't forget, this has in front of it, no, I didn't mean that. This has in front of it at 1/4, so 0.25. Okay, so from 0 to 4, don't forget that because otherwise you're not going to get me. Be careful what you enter in here. Do not enter the derivative, the function that you get at the end. You have to enter the original function, which is the derivative, right? Plus x, and then minus 2, and dx. So when I click enter, I have to get 16 divided by 3. If I don't get 16 divided by 3, then something is wrong. So we did get 16 divided by 3. Good, very good pick. So now, oh, I didn't mean to stop sharing. Sorry about that. I meant to go here. Good, so this is pretty clear, right, what we need to do here. Is there any question on how to find the average value of a function? Okay, so then let's move on to some word problems. Let's look at memorizing. We're all interested in being able to memorize.